Well, good morning. This is Becky Mueller, the North Dakota Afterschool Network lead. Thank you for joining us today for our 3D Printing for Your Classroom webinar. This is the first of 3 webinar sessions that we'll be hosting this year, and I am super excited to have Shannon Blocker from Charism here to be our presenter today. She got to spend some time with Digital Harbor, who does maker spaces and was at our summer conference a couple years ago. They do a train the trainer on 3D printing, which includes a statewide competition. So super excited to have Shannon here to share her experience and her 3D printing knowledge. So I am going to turn it over to Shannon.
Perfect. Good morning. So today I will be just sharing some of the things that I learned from the webinar or the training at Digital Harbor in regard to the 3D printers. So what I'll do, I think I'll start with just giving you some basic information, and then I'll give you a couple of websites that we can kind of play around in and explore. Great websites that you'll be able to use in your classroom. And then I will kind of wrap it up with some other information in regard to the filament and the plastics that you can use. Ideally, this webinar would be great if you have a printer, a 3D printer already. Some of it might make more sense in saving files and downloading them and converting everything over to a 3D printing software. But if you don't have a 3D printer, that's okay. Again, this is just a lot of basic information that that I have for you just in regard to 3D printers. So we'll get started. If you have any questions throughout the webinar, feel free to write it in the chat. I think I can hear everybody, but it might be easier to have it typed up. And then if you have any questions at the end, you can feel free to ask or reach out to me. Before we start, are there any questions? Okay. Well, if you can see. All right, so why use 3D printers in your classroom with youth? Well, first of all, the one thing that I learned is that using a 3D printer in your classroom or out of school time setting with after school or summer camp, it gives the students the freedom to explore and find their interest and develop their passions. So if you can think of something basically that you can create in a 3D software, the kids are probably going to be able to 3D print it. And again, that will develop some of their curiosity and their interest and their passions. This is the 3D printer that I have at home. It's called a Flash Forge Finder. Flash Forge is the brand of the printer, and then Finder is the model of the printer. This printer is fairly affordable. I think it's between $100 and $500. And if you can see right where it says Flash Forge, you can see that build plate. I'll talk about that in a little bit. But that's the plate where the 3D object will be printed on. And that build plate can print about 5.5 inches by 5.5 inch object. So it's a little bit smaller, but it's a great starter printer for teachers in a classroom. There's an LED screen on the top that gives you a lot of step-by-step instructions. It will walk you through how to set it up. It's really, really user-friendly, and it's easy for kids to use as well. So if the kids decide that they want to build anything that's bigger than 5.5 by 5.5, they can print multiple pieces and screw them together, glue them together, or attach them somehow. But so some of the 3D printing benefits that you can have in your classroom is that you can use it as a prototyping tool. So one thing that we learned is that teachers should use 3D printers as a rapid prototyping tool. So it's a great way to incorporate the engineering design process. You can start with a challenge, and I'll talk about the process later on. But it's great to use the engineering process because one step in the engineering design process is to revise or to reinvent. So if students are creating something that doesn't work, they're able to go back and redesign and reinvent their ideas so that it will work for them and what they want. So it's a great tool to prototype really fast. With 3D printing, you can also make personalized and customized objects. A lot of teachers and students use a keychain as their first kind of 3D printing project, just because it's really easy, and a lot of students are able to add their names to it, add shapes that they like, interests, sports, things like that. And then also another 3D printing is that they can do print and manufacturing. So 3D printers use digital files. Um, I usually save everything onto a USB drive, and I can put it in, and I can connect it to my printer, so there's no need to save inventory in a classroom or anything like that. So what is 3D printing and how does it work? There's two types of 3D printing. There's something called additive manufacturing and another thing called subtractive manufacturing. So if you can see in the picture, an additive manufacturing is a 3D printer that works one layer at a time. So if you can kind of think of it as a hot glue gun that's controlled by a robot arm, it can go back and forth, up and down, and it will extrude 3D printing filament on your build plate, and it will build layer by layer. Subtractive manufacturing is a little bit different. It's not as common as additive manufacturing, but it is something that you can still do. Subtractive manufacturing is basically just carving away the material to make an object. So if you think of a sculptor who is sculpting something out of marble or a wood or an ice sculpture, that would be subtractive manufacturing. And just because if you have a big object and you're carving away at it, it's going to create more waste, and you're going to end up using more filament. So it's not always the best option. There is something called a carving machine, just pictured here, and a carving machine is just another type of a 3D printer that, as you can see, it carves away these objects. Last time I checked, the carving machine is a fairly new product, but I know that they have some competitions or applications that you can fill out to get a free carving machine in your classroom. I don't have a lot of information on that, but I think if you check out their website, you'll have more opportunities to win or get a carving machine for your classroom. This next slide here is just another visual of the two different types of printing, the additive and subtractive. So if you look at the figure A, that would be subtractive manufacturing. You can see you have your square block there. It cuts it away, and it creates your 3D object, and you have all this extra waste. The additive, again, just to reiterate, the additive 3D printing object, you start with your material, which in this case would be a spool of filament for your printer, and then by layer, and then you have your 3D object, and there's not a lot of waste. Sorry about the changing of the slides. All right, so how do 3D printers work? There's a couple parts to it. There's the filament, which comes in spools, and if you look at this diagram here, you can see the filament spool. And the filament is really cool for kids because it can come in a wide variety of exotic filaments, which I'll talk about later. But you can purchase filaments that are infused with wood or metal, or you can get magnetic filament, things like that. So the opportunities are pretty endless. The next part of a 3D printer is called the extruder, and if you can see on the image of that diagram, you can see the extruder there, and that is what feeds the filament into the printer. So there's little gears that will grab the filament from the spool, and it'll push it through the extruder. And then at the very end of the 3D printer is called the hot end. And that is that's where the filament comes out of and will set on your bed plate or your print bed. The hot end gets really, really hot. That's one kind of safety feature to talk to with kids, is to make sure that they are not touching that hot end. It can get up to 220 degrees Celsius. Working with students, I've never had any student injure themselves with a 3D printer. They're pretty safe unless you're really trying to touch it or get your fingers in there. It's pretty easy to avoid. So one other thing I wanted to talk about with a 3D printer is the infill. And an infill is a setting that you can set on your 3D printer. Most people use 15% to 20% infill for printing 3D objects, just to save on filament. I would avoid 100% infill, just because it basically it fills the object 100%, so you're wasting a lot of filament. Your object will obviously be stronger, but if you're just doing gadgets and toys and easy 3D basic models with the kids, a lower infill would be just fine. And if you can see in the image below, you can see on the, I don't know what this yellow wrench looking thing is, but the top image you can see is 100% infill, and then the bottom image is an infill with, I think it said 17%. So you can kind of see how it's cross-hatched, and it doesn't fill up the whole space. Are there any questions? All right, so the next part, or the next step in a 3D printing with your classroom would be the design to print workflow. So this is a lot of information that I'll go through with you, but if you do have any questions, let me know, just because the vocabulary can get a little confusing. But basically, you start with the design software. And the design software can come in many shapes and forms. You can have 2D models, you can have 3D models. But the design software is, the most important thing about design software is that it exports your 3D printing file to an STL file, which stands for stereolithography. Almost all of these design softwares that we'll work with, most of them will have the option to export into an STL file, or called your mesh. So you can think of it like a wire mesh that defines your object structure, like a paper float or a paper mache creation. So if you can see this picture of this monkey here, the first image, image A, that is going to be your mesh STL file. You can see that it has it's just the outside kind of wiring to the image, and you can also see that it's just the surface of the object. It doesn't include any information about texture, about color, any other things that you would see on the surface of your object. It's just basically kind of like the middle or the inside of the image. So I'm not too familiar with STL files. I just know that your 3D printer needs to print in an STL file. But once it is able to be compact, it will go into another section of the design to print workflow, which is a slicing software. So if you have your design software, basically you're creating your object in a design software. For today, I will be showing you two different softwares. One will be called Cookie Caster, and another one is called Tinkercad. Tinkercad is really popular with teachers and students because it's easy to use, but that would be an example of a design software. So you have your design software like Tinkercad, and you create a solid 3D model in that software. Once you're done creating that model, then you will output it into your slicing software, but you'll output it as an STL file, and that design software will do that for you, so you don't have to worry about that. Once you put it in, once you send it to the slicing software, which would be a 3D printing software that you can probably download that comes with your 3D printer. The slicer takes your design and slices it into individual 2D layers. So again, if you look at that monkey image, the second image B, you can see the different 2D layers or sliced sections. The slices can be thick or thin depending on your settings. That's all preference. Once you send it through the slicing software, it will cut the object into different slices, and then it will translate that STL file into a G-code file, which is what the printer software will read. So it's a little confusing, but your design software you'll create your object. Um, it'll change it, it'll export it to the STL file, it will slice it, and then you can send it to your 3D printing software. For example, mine would be FlashForge. And then the 3D printing software will go ahead and take that STL file and export it or change it into a G-code file. Let's see. The software is actually the software printer software is the software that actually controls your printer by sending commands to it. So most often, again, you'll use a G-code file, and the software will send each line of the G-code file to the printer. It's a little bit confusing, but once you practice it and start saving your 3D models from your design software to your printer software, once you do that a couple of times, you'll get the hang of it, and it'll be really easy. Are there any questions about the design to print workflow? All right, so I'll just move on. So, so now that you know the design to print workflow and how a printer somewhat works, you can go ahead and start thinking about how you can use the 3D printer in your classroom. So I'll talk about the process of making stuff in a second here, but just some information to keep in the back of your head when making with youth is that when you use 3D printers, it helps students to develop a productive habit of mind. So students will learn a lot of great 21st century skills working with 3D printers and working in teams that use 3D printers. So they'll learn to adapt, obviously solve problems. Creativity is one of the most important things that I think 3D printers can offer. Students will produce products, they collaborate, they become curious, they develop drive and internal motivation. And then again, always with working with STEM and technology, I always like to incorporate STEM careers with students as well. So obviously working with technology such as 3D printers will help youth prepare for the unknown future. So obviously in the future, jobs are going to be impossible to predict, and they require people who can easily adapt and who can easily collaborate and produce. And teaching those students how to use these 3D printers will help with these skills. All right, so the process of making, when you're working with students, it's important to focus on this process. And as an educator or as a teacher or after school coordinator, it's using 3D printers, it's important to know that it is about the process and not the product. The product will come later, but the process is the thing that's most important. And then while you're in the process of making, as an educator, it's important to have check-in points with the students to review incremental project or progress. So if you have students, if you're working on a project with a 3D printer and let's say you're using the engineering design process, I would maybe have some check-in points with students, maybe at each step. Before they start actually 3D printing stuff, you can check their brainstorming notes, their collaborative notes, their designs, what they plan on doing before they actually start printing. So with the process of making, it's always start with a challenge. You can have students solve a problem, fill a need, or answer a question. And with this challenge, especially working with something as fun as 3D printing, 3D printers where students are able to open up and be more creative, it's important to give the students a choice. So make sure, so with this challenge, caution against students having the same output or project as everybody else. And then make sure that students have choice in the themes or the topics, the materials that they're working with. The design tools, maybe there's some students that aren't interested in Tinkercad, so allow them to explore other options that they might be interested in. And then obviously have a choice in the solution that they come up with for the problem or question that they're answering. And then also give students the opportunity to find their own problem to solve. I feel like it's too common in classrooms and after school settings where the teacher or the mentor or educator is giving students the problem that they need to solve. I always find it's more meaningful if students come up with their own problem, just because if they're coming up with it themselves, it's probably something that they care about or they're interested, and it's going to create a more meaningful experience for them. So once you establish a challenge, then you'll just kind of follow through the engineering design process steps. And the next step would be to design. Again, implement the EDP, have students work in groups to design, brainstorm, sketch, hypothesize, record. And they can do this on paper, they can do it in science or engineering journals. They can do some of the sketching in 3D software, 3D modeling softwares on the computer. So there's really a lot of options for that. After you design, again, a nice time to check in with students to check their progress, then give them time to make. And you're going to need a lot more time than you think for students to make things, just because, again, that rapid prototyping, if they create something in a 3D model and they print it and something is wrong, then they have to go back in that 3D model and double check and revise and 3D print it again. A lot of times these steps, kids will print up to 6 or 7 times before they have their final project that they want. And if you only have one printer and 15, 20 students trying to use that printer, you're going to need a lot of time with that. So with the make, they can build, experiment, fabricate designs, review, revise, and work from their original design. Again, a lot of this is inspired from the engineering design process. Lastly, allow students to share and market and publish and teach their design and what they've made and summarize. So a really great project to do with the kids would be some sort of marketing tool. Have students create something that they'd like to market, and then you can follow through and have them advertise it and kind of be their own entrepreneurs and publish some of their stuff. One thing to be careful with, and I'll talk about this later when we look into the design softwares, there are a lot of resources out there that students are able to download already made 3D modeling files. And I'll show you that later, but just make sure that if students are taking something that somebody else has made, make sure that they acknowledge that and they publish or they give I guess I don't know the word for it, the right public I guess the copyrights, the rights to the object. So if the students want to print something like a keychain that has a sports logo on it, that's something that you might have to look into about copywriting and things like that. I think if they're just creating something in their classroom for their personal selves, that wouldn't be a problem. But if you get into the marketing and the entrepreneurship where they're actually creating things in bulk and selling them, then you have to be careful about copyrights. Learning together. So with the 3D printer, as a teacher, it's important to let kids know that you don't have all the answers, and that's okay. And that it's important that kids know that they can work with their teacher together to figure out their problem or the problem. The 3D printing is creates a great environment creates a great learning environment for teachers and students to work as a team together. And then lastly, in the making process, it's really important to set expectations. So a lot of kids see 3D objects that have been printed, and some of them are really complex and immaculate, and that's great. But as a beginner, some students may not be able to create something like that right away. So it's important to set expectations. Make sure that you limit the time frame for project work. If you give students unlimited amount of time, they're just going to create and create and create, which is great, but they might get off task what they're supposed to be doing. So if you can talk to the students and maybe set a goal, maybe you want to set it up in those incremental steps from the process. So maybe you want to give students X amount of time to work on their design, or X amount of time to brainstorm the solution to their problem, things like that. Another expectation in the classroom is to manage frustration. Kids will get really frustrated. I've seen it. It's important for them, for you as an educator, to teach the students that it's okay to fail. That comes again with the engineering design process, with revising and reinventing your object. Failure isn't really failing; it's just making a mistake and learning from that mistake. So, and then as well with that failure and that frustration, you might run into getting students getting disappointed, and that's just because obviously if they've worked so hard on something and then they print it and it doesn't work out, they may get discouraged and disappointed. But it's important to teach that resilience and keep them moving. And to do that, you can encourage grit and determination. So one thing, before I get into design softwares, one thing that I don't have a slide for, but I wanted to mention is creating something that starts in 2-dimension and creating it into a three-dimensional object. And if you're working with elementary school students, they really struggle with that. So maybe before you work with the 3D printers or design softwares, help students understand that concept. And basically what a 2D object is something on a flat space with an X and a Y coordinate. So if you draw a circle on a piece of paper and you let students know that that's a 2D object, a good inquiry question would it be to ask the students what would they need to add to this circle to make it a 3D object. And you might get varied answers, but the correct answer is that they need to add height to that 3D object. So if you add height to a flat circle, it will turn into a 3D object or a cylinder. And some easy strategies to teach that would be having students draw 2D shapes on a piece of paper and then working to build up into that 3D object using height. So there's a lot of different ways you can do that. You can one of the ways we'll be using Cookie Caster, which I'll show you in a second, but you can also use something called DoodleFab, which is another 3D software, or if you've heard of WikiSticks. I've just learned about them, but they're like pipe cleaners, but instead of wire and the fuzzy part, they're wax. So it's just like really thin wax sticks. So if you have a circle and you give these WikiSticks or pipe cleaners to students and you have them use the sticks to cover up the lines that they've drawn, and if they build up from that, that might be a good visual strategy for teaching students the difference between 2D and 3D. Let's see. Another way that you can do 2D to 3D modeling with kids, or showing them how that works, is to do figure modeling. So you could have a drawing and you could get wire sculptures or wire frames, or again pipe cleaners, and you can get clay models and you can fill in the wire frame with that clay, and that should show them how to create more of a 3D object. Prototyping is really important. Again, we talked about prototyping, but that's just making sure that youth are prototyping all of their projects, whether they're in 2D or 3D, but they can be as simple as a sketch, or again, it's something can be more complex where you're building up that height and adding it and making it a 3D object. So right now, I think we're going to go ahead and explore a little bit. So if you have access to the internet right now, if you could type in cookiecaster.com. And I just want to introduce you to this website because, again, it's a really great opportunity for younger students to see that 2D shape or model transfer into a 3D model. So let's just maybe, if you want to add in your chat, if you're on the website or if you're good to go, then I can go ahead and move forward. All right, so Sheila, if you scroll down into the wood part of the website, I already opened, but does it say for you something about a tutorial or something where you can click sure I love cookies? Okay. Yep, you can go ahead and click on that, and Sheila, that will bring you, that will just give you a quick tutorial on how to use this website. Basically, it's a website where students can draw or trace different objects, different 2D objects, and then transfer them into a 3D model or 3D cookie cutter. So if you can see my design, if you can see the image in the web or on the screen that I'm sharing, I'm just going to do a basic square, and you can see in this 3D, and then it will automatically convert into a 3D object, and I can rotate it around and move it like this. Some of the sizes you can change the sizes to your preference. I would go ahead and, if it was me, I would do a 3-inch max size and 0.4-inch height, and that's just kind of a common default that I use. And then for the thickness, just to save on some filament, I'm going to go ahead and change the thickness to 1.5 millimeters so that it's thinner. Yeah, this is a great website to use with the kids. Another opportunity that you can do, I haven't done it, but I plan on doing it in the future, is having, this is a great website and easy to use for kids. So it would be a great idea to have some sort of parent or family fun night where parents and kids can come together and create a cookie cutter, and they can print it for the holidays or for birthdays or whatever kind of family fun night that you want to have. Since it is around the holidays, it would be a great time to do something like this. But also just getting parents into the after school programs is a big challenge for me. So I think that this would be a really fun and incentivizing way to get parents in and get kids working with their parents and showing them what they can do. So there, if you keep looking around this website, it does a little bit more than just being able to draw 2D objects. Just to save on time, I won't go into everything, but you can go ahead and if students aren't really interested in creating the model on the computer where I'm drawing right now, they're able to draw it on a piece of paper, and they're able to take their picture and they can hold it up to their webcam, and it will automatically, or you can upload it into this Cookie Caster website. So if students are having a hard time manipulating the different shapes and the different buttons here that you can use, if they'd rather draw, they're more than welcome to do that. Tinkercad, I'm going to bring this website up really quick. This is a 3D model that I drew. It's just a little toad head from Mario Kart. This is something that I drew on a piece of paper, and I entered it into Cookie Caster and eventually saved it into Tinkercad. So really cool, different options that you can do with the kids. And like I said, it's great to do as like a family fun night to bring in parents and family. So go back to that Cookie Caster. Are there any questions with the Cookie Caster website? All right. now I'm going to go ahead and move forward. So another website that I wanted to share with you, and this is the one that I use most common, it's called Tinkercad. If you guys want to go ahead and create an account and log on to Tinkercad, I'll give you some time to do that. But if you have an account, it might be a little bit easier to show you some of the different things that you can do with it. Yep, great question. All these resources are free. The Cookie Caster one is free. Again, you just download your STL file into your printer software, and it will transfer it to a G-code for you, and then you'll be able to just print it as is. So the only thing that will really cost you money is obviously your 3D printer, and then if you're doing something like a parent night, you might want to have some extra rolls or spools of filament on hand, just in case you run out. And again, I'll talk to you about filament in a little bit and kind of how long it lasts. But yep, everything is free. So with the Tinkercad website, it's I love this website because it's easy to use, and as an educator, you can, let me show you my notes right. As an educator, you can create a classroom account, and under that classroom account, you can set it up that students can have their own accounts within your classroom. So when you log onto your classroom account, students will be able to log into their specific account under your classroom, and they can work from there. And they'll have all of their designs and all of their work in progress saved right into their account. And as a teacher, you can show them how to do that, and you'll have access to all of their stuff as well. I have never brought in any engineers to do this yet. I haven't introduced 3D printing into the middle school classroom that I'm working with now. I plan on doing it later on in the spring. We're actually doing a challenge where students will have to 3D print paddle boats, and we'll eventually race them. But they have to they're going to be having to build 3D printing paddle boats, and their boats must be powered by a rubber band or something else that's not electric. So example, they can't use motors for their boats. But something like that, when we do that activity or that challenge, I'll definitely be bringing in engineers to help out with that. Another great person to connect with, and this is specific to this challenge, using boats and water and things like that, but there's Navy recruiters, U.S. Navy recruiters in the area that are always more than willing to come and talk to the kids about what they do. Not necessarily recruiting them, but just talking about what they do on a daily basis, especially specific to boats and submarines and things like that. I know that the middle school students I work with are really interested in that. So, all right. So I hope you had enough time to create an account. But if you look at the screen that I'm sharing, there's a couple different options. This is you can see these are all the 3D models that I've created or have revised, or it's something called remixing. So that's taking somebody else's 3D file and changing it and adding it and making your own. So you can see this keychain right here. This shape would be easy to create, but I just found a file of it, downloaded it into Tinkercad, and then added my own text to make it my own. So with this Tinkercad, if you click on Learn, this is going to be really great for teachers. I would highly recommend going through each of these steps before you let the kids loose with it. Just because if the kids have questions or if they get confused, you would have already gone through the course and you'll have more information for them. But as an educator, definitely go through it yourself, and then when kids create their own accounts, this is a great starting kind of a starting hook lesson to get kids hooked into 3D modeling and 3D printing. So if you click on, sorry, my mouse is kind of weird here. if you click on the first, or you can see up here, this new circuit is an addition that they added, and I haven't looked at it since the last time I've logged on. But again, you can always hook up your 3D printers with Arduino boards and things like that. But if you just want to click on, I want to learn about 3D design, and if you scroll down, it will have step-by-step lessons. So if you click on the first lesson where it says learning the moves, it will, it might not work for me because I already did it, but I should be able to redo it. Yeah, so it says over here, congratulations, I did it, but you can go ahead and follow the steps that it says on your computer since you haven't done it yet. It will show you how to use just kind of how to manipulate the website. So for example, I'll just kind of show you just something really quick that I can do. Here's a box that I created, or I drug over, and I can make it bigger or smaller. And then if you look in the top section where it has the box and the cylinder where it's grayed out, that means that it will, if you put that in your object, it's going to, it will kind of be that subtractive 3D printing where it will eliminate that section of the model. So if you see here, I have my box, and if I just drag in another box that's shaded, I can make it a little bit bigger. And if I combine these objects, if I group them together, they will be, oopsies. If you right click your mouse and drag your screen around, you'll be able to view it at different angles, which will be really helpful for kids when they're doing their prototype, because obviously it's going to be different one way that they look at it. So here I'm creating my box. You can see, sorry, my mouse is kind of lagging. You can see this little arrow right here. I'm able to drag it up and down. And if I do that, and then if I group these together, it should be a hollowed out box like that. So I think that is something that you'll be able to learn really quickly in these steps here that you're going through. Is everybody getting this okay? Are you able to log in and start some of the courses? Should I be wrapping it up?
You're good. We don't have to.
Okay. So yeah, go ahead and explore. There's a couple of lessons and tutorials for each section, and as kids are going through it as well, you can see that it's very responsive. It will shoot out stars once you've completed it or once you've got it right, and then it will tell you if or when you're able to move on. The first learning the moves tutorial kind of shows you some shortcuts to different buttons that you can use on your mouse. Like I said, if you right click, you're able to move the design around. You can also click up here if you want the exact front or bottom or side image. You're able to click on that as well, which also helps students visualize their objects. One thing you'll have to be careful with in teaching kids is that their objects are flat on the ground. If you have your object in the air like that, and if you click, you can see that empty space. 3D printers can't print, they can't print in the air. So that would, if they tried doing that, it would come back as an error message. And just again, encourage students to check out all angles of their model and make sure that everything is connected and flat on the ground like that. So as you explore through there, again, I mean, you could spend probably a couple hours on learning these skills, but I just kind of wanted to show you where that learning tutorial section was. And again, if you do this with kids, I highly recommend making it mandatory that all of them go through those learning tutorials before you get started. Yeah, you're fine to play with it. Are you able to manipulate it on your site? Oh. Yeah, you won't mess anything up. It's just the tutorials on your account. And then if you click on the Teach section or the Teach tab up in the top next to Learn, that is where you can create all of your accounts for your students. And again, to save on time, I'm not going to do that, but I just wanted to show you where that was. This website is really, really easy to use. It gives you step-by-step instructions. But if you are interested in creating your classroom experience with this, and you're still confused on how to set up an account, you can shoot me an email, which I'll send in your chat. And if you have any questions, you can ask me.
All right, so that is ThinkGiveRse. Another thing that I want to show you is a website called THINGIVERSE. And this website is a really great website for all of those already created 3D models that you or your students might be interested in. So I have it up on the screen here, if you can see. You can search for any item. So I know that like Star Wars is really popular with middle school students right now. So you can see that they have, somebody has already created these 3D models in something like Tinkercad. Not necessarily Tinkercad, but a different 3D model.
And then they've uploaded it to this Thingiverse for everybody to use.
So you can kind of scroll through here.
If you click on one of these little guys. So you'll be able to, now you'll have the 3D model files to send this to your printer software to print yourself.
One thing with using Thingiverse is that you want to click on, instead of print details, you want to scroll down here and click on print files. And then these are going to be all the STL files that you'll send to your printer. So this one looks like it's in multiple parts, but you can see all the different pieces that you can print to put together this character from Star Wars. I don't have the Flash Forge Finder software downloaded on this computer since I'm off-site right now, but if you just click on a file, you'll want to send it to your 3D printer software, because again, that will automatically take the STL file, that kind of layer outside image, and it will slice it into those layers, and it will transfer it to a G code file in your 3D printer software for you. This Thingiverse website is really great for kids. You're able to take some of these files, and you're also able to upload them or open them into Tinkercad. So if you had something like this little green llama up here, and kids wanted to add shapes to it or add more to it, add their name, they would be able to do that in Thingiverse. Tinkercad. I wish I had more time to work with you on Tinkercad today, but unfortunately we don't. So again, if you have any questions about that website, please feel free to reach out, because it is a really great website and you can do a lot of things with it. Also with Thingiverse, if you look at the top here, they have kind of a scrolling menu. They vary monthly, but every once in a while they have Thingiverse competitions, which is great to include in your classroom, because everything is already set up for them, and the kids just have to create something to compete in it. They can win. The winning prizes on some of these challenges are really awesome. Some of them are like
Lego sets that cost hundreds of dollars. A lot of the prizes are technology related to 3D printers and things like that, which is really cool for your classroom.
Are there any questions about Thingiverse?
Perfect.
All right, now I'm going to go back and talk to you about the filament a little bit. So depending on what kind of 3D printer that you have, you're going to need to purchase specific filament for it. So there's different types of filaments. The most common filament is PLA, which stands for polylactic acid. And that is, if you look at these colorful spoons down here, that's your PLA filament. And again, that's the most common. It's made from cornstarch or sugar. And you can always tell when you're printing with PLA filament because when it prints and when the plastic is melting, it kind of smells sweet and syrupy just because it is made out of sugar. And then PLA filament is really nice because it also decomposes into water and carbon dioxide within a couple of months. So if you're worried about that, it's nice that that decomposes. Another filament is called ABS. I can't remember what it stands for, but the ABS filament is a little bit more expensive. It comes from petroleum, and it works with a higher heat than the PLA does. So if you have a 3D printer that requires ABS filament, you probably have a more high-tech or complex printer. A lot of times, the ABS filament will smell really bad, like plastic or styrofoam when printing. And the ABS filament, you need to use a heated bed or build plate with that. So I'm going to go back to this image right here, and you can see that bed plate that I'm circling. That some 3D printers have build plates that can heat up, and that's a little bit more complex for kids, but the heated bed filaments you can do more with. So a lot of times if you're printing with a metal filament, you'll need to use a heated bed. And it's just because it heats up the metal to a hotter temperature, and it'll be able to stick and build better on a heated plate. So those are the two main types of filaments, PLA and ABS. Again, PLA is most common, but then they also have exotic filaments that you can purchase. And if you ever purchase those, just make sure that they're compatible with your specific 3D printer. For example, if you get the metal infused filament, again, make sure that you have a heated bed. But you can get flexible filament. You can get filament that has that's infused with wood. Or carbon fiber. I've actually been to a conference where people created filament out of recycled coffee grounds and made coffee cups out of them, which was really cool. You can get scented filament, you can get conductive filament, there's cork infused filament, you can get thermoplastic filament, so if you touch it, it changes colors if your hands are hot or cold. And then you can also get magnetic filament. So filament varies. It varies greatly. You can get a spool of PLA filament for about $20, depending on your budget, or some of the other spools, the more exotic filaments, can go for up to $150 to $200 for a spool of filament. So it really is affordable if you're working with kids and you don't need the best of the best. But yeah, so I would say around $20-25 for a spool of filament. And some things to consider when you're getting filament is the thickness. There's two different sizes. There's a 1.75 millimeter and a 2.85 millimeter. I think again, the most common that I use is the 1.75 with that PLA. And then you can get different weight as well. You can buy filament almost anywhere. I would prefer Hatchbox just because that they're the cheapest and it's kind of the best bang for your buck. They have some exotic filament if you're interested in that, but they also have a really wide variety of color. So I'd prefer Hatchbox, but also there's these other sites that sell filament as well. One site I would avoid is SaneSmart. And I would avoid it just because their thickness varies. I've never gotten any filament from there, but I've heard that their thickness can vary
and it's not always universal with all the other filament spools that you can get. So so just be careful with that. And then a lot of people ask, how long does a spool of filament typically last? So if you can think of a little keychain that you can make, I know I had an example keychain in the Tinkercad website, but if you think of just an average keychain size, you can print about 200 keychains with one spool of filament. So, and that's something to keep in mind too. If the kids are rapid prototyping and screwing up and reprinting, obviously that filament is going to go down a lot faster. But another comparison for filament would be if you had an iPhone 5 case. If you had a spool of filament, you'd be able to print almost 100 iPhone 5 cases. If you're thinking of an average chess piece, a spool could print 103 chess pieces. And then if you're also, a lot of people create, with the cookie cutters, they create molds for like chocolate and things like that. And depending on your size of your chocolate molds, you can get almost up to like 350 different chocolate molds. So that is something too with the spool and how long it'll last. That if you have older students, that would be a good way to incorporate math, figuring out, how many pieces of this product can you make with one spool of filament. If you have math students or if you have a math class, that would be a really great way to incorporate that into your lesson. Also for entrepreneurs, or if you're doing some sort of marketing activity with the kids, as an entrepreneur, it's obviously important to figure out those costs and understand how much product you can get out of filament. So we have a couple more minutes left. That's all I have for you today. But if you have any questions, feel free to type them or ask them now. Otherwise.
Well, I just want to say, while we're waiting for some questions, if there are any, thank you so much, Shannon. This was very educational. I'm super excited. I hope that people that are on the line will be able to utilize the information that you gave them. I feel like those free resources are amazing. Even if you don't have a 3D printer, to create the 3D image on those sites would be awesome. But I'm going to post this webinar on our website. So for those of you who are on, if you have other people that you think, oh my gosh, I should share this with so-and-so, please do so, and that the webinar will be on the website. So they would be able to watch it there. I guess last call for questions. If not, thanks again, Shannon. This was great. And happy 3D printing, everyone. Have a great day. Bye-bye. Can you stop recording?